Hello there. So today we'll start with our formal study about motion. So what we'll do in that is that let's say there's a boy named Sam. So here I'm having a boy and his name is Sam. So Sam is a curious boy. Now he's curious about what? So he's curious about why the things move and how they move. So there's a curious guy named Sam who wants to know why the things move and why the way they move. So if they are following a particular way, why they are moving in that way. So we'll try to answer how they move in this particular chapter. We are calling it kinematics. And we'll try to answer him that why the things move in a separate chapter, and we'll name it as dynamics. So let's try to solve some of his problems. So the first problem was, the Sam said that if I am here, so this is Sam who is here at his home and he wants to reach his school, which is here. So Sam was at its home. So Sam is at its home and he wants to reach school. Now the path to Sam's school is something like this. So on daily basis, Sam was following this path, then this path, then this path, then this path, then this path, and this path. Then Sam tried to understand that how much distance I am traveling actually, or how much path length I am traveling actually. So he took a meter scale and he tried to measure this distance. So let's say this distance was, let's say, 1 meter, or I have made it small, so which means 1 kilometer is equivalent to saying 1 meter. Then he moved 2 meters in this direction. Then he took a turn and moved 2 meters again. Then again he took a turn, he moved 1 meter again. Again took a turn, 1 meter, and lastly he traveled 1 meter and he reached his school. So first question which Sam has, that how much distance I have traveled. Then the answer was 1 plus 2 plus 2 plus 1 plus 1 plus 1. So that means 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 1 is 6, 6 plus 1 is 7, 7 plus 1 is 8 meters. So Sam said that daily basis I am traveling 8 meters, which is equivalent to saying 8 kilometers. And this is what Sam is traveling on daily basis. So on daily basis, how much path length Sam is covering? It's actually 8 kilometers and we call it distance. There is no new thing in that. Sam is traveling a distance of 8 kilometers on daily basis. So this traveling distance is what we call, for your clarity, it's what we call distance. All of you are already aware of this. So distance is actually the actual path length covered by the person, and in this case distance covered by Sam is 8 kilometers. Now the question Sam asked is that if I'll make a road, straight road from my home to the school, then how much distance I need to cover? Then the answer he found was he'll have to travel 2 meters in this direction, then 1 meter more, and then 1 meter more. So now he got to know an interesting fact. The interesting fact was that if he's going straight from his home to his school, and if there is a road, then he'll just have to travel 4 meters. which is equivalent to saying 4 kilometers. Now, when the Sam was following the actual path, it was 8 kilometers, and when Sam thought that if somehow I can go straight away to school, then only I'll have to travel 4 kilometers. So distance got halved. Can Sam make a distance smaller than this in order to go to school? And the answer is no. This is the smallest possible distance between Sam and his school. So now Sam gave a name to this, and the name he gave to this was displacement. So what we understood from this point? The point is the shortest distance between 2 points is what we call displacement. So the actual path length is what we call distance, and the shortest possible path length between 2 points is what we call displacement. Let's take an example to understand it better. So let's say if a particle is there, it follows this path and reaches this point. Then the actual path length covered by the particle or the person, or for example Sam, is this length plus this length plus this length plus this length, and the same process will continue. And if you'll add all the lengths, you'll get the actual path length the particle is covered. So if I'll write down the actual path length covered by the particle during the course of motion, we call it distance. So this actual path length covered is what we call distance. Now, if this particle has to cover the smallest possible distance in order to reach point P, then the particle will move in a straight line and will go to point B. Now what it means? It means that this is the shortest path length between 2 points A and B. And just now we introduced the concept of displacement. So what we call it? Displacement. Now let's say there's another particle or a person or Sam itself. So now goes around a closed loop and comes back to the same point. Now this is an interesting question. What's the path length? Then path length will be the circumference of this circle. So the particle started from here, it traveled this distance, and then came back. So the actual distance is actually the perimeter or the circumference of the circle. But if I'll ask you about displacement, then the initial and the final points are same. Since the initial and the final points are same, the distance between them will be 0. So what do we mean by that? We mean by that is displacement of this particle is 0. Because the smallest possible distance between the initial and the final point is 0. So displacement in this case is 0. Let's take another example. Let's say now this particle moves in a half circle and reaches this point. Now if I'll ask you the same question again, you will say the distance will be perimeter divided by 2, because it is now covering half of the circle. But if I'll ask you about displacement, then you will say first of all I need to identify the straight line path between point A and point P, which is this distance. And we all know it's a combination of two radii and we call it diameter. So displacement in this case will be the diameter of the circle. So now I hope you got the picture. The picture says that if a particle is in motion, then it can cover two kind of lengths. One is the actual path length and one is the shortest path length possible between 2 points. Now, the actual path length can be greater than the shortest path length. That's why we are naming it shortest, right? So the actual path length can be greater than the shortest path length, or in other words, we can say distance can be greater than displacement, or distance can also be equal to displacement. When this will happen, the distance is equal to displacement when the particle is moving in a straight line path. So what conclusions we can make here? We can say that distance which we are talking about, so distance can be greater than displacement, or we can say magnitude of displacement. We'll talk about magnitude and direction and all those stuff in a different section altogether. But distance can be greater than displacement, or distance can be equal to displacement. Now, in which case distance will be greater than displacement? Sam's traveling from home to school is a clear-cut example of distance and displacement distinguishing, and in this case distance is greater than displacement. Distance was 8 kilometers and the displacement was 4 kilometers. Now, when distance will be equal to displacement? When the particle or the person is moving in a straight line path. So if, let's say, there is a particle A here, it moves in a straight line and reaches point B. So in this case distance will be equal to displacement. So in which case this is possible? When the motion is straight line motion, or other name for this is rectilinear motion. So when the particle is moving in a straight line or following a rectilinear path, then in that case distance will be equal to displacement. So I hope now you got the picture of what the distinction between distance and displacement is, and how to distinguish distance and displacement, and what are the constraints that govern distance and displacement. Constraints like distance can never be less than displacement. At max, distance can be equal to displacement or greater than that. So study all these things, bear all the things in your mind, and see you in next class. Thank you.